The important question in thermal physics, I think that is about the specific heat and about the latent heat. So this question is about specific heat or latent heat, which formula will be valid here, how to check that. So this lecture is about that. Okay. So this is just an investigation, right? So we have some sample of water, random sample of water, and that random sample of water is under some investigation. That is the investigation of a student, right? So what he investigate in that sample that is given here, we are given a mass M1, which is at 100 degrees C, it just before boiling starts, right? And just before the boiling starts, the sample contains mass 120 gram. Just before the boiling starts, we have a sample of water, right? So that is at room temperature now. So we start supplying heat energy by the heater, right? And slowly, the temperature will rise from the room temperature, right? Assume the room temperature is 28 degrees C. Slowly, it will rise from 28 degrees C, then finally it will reach to the 100 degrees C, right? Where the boiling starts. But this is about just before the boiling, right? Just before the boiling, a few moments before the boiling starts. Now the question is that before we just solve it, the question is that how will we come to know that this is a problem related to the latent heat? Why it is not related to the specific heat capacity, right? The reason is very simple, right? In this question, there is a very good clue, that is this temperature. When the temperature remains same for two different masses, when the temperature remains constant, then apply the formula of latent heat. Clear? When temperature remains constant for two different masses, then without any hesitation, without having a second thought, directly apply the formula of latent heat of vaporization, right? Or latent heat of fusion. But because this question is about the vaporization, because 40 gram is evaporated in this process, so we will apply the formula of latent heat of vaporization, right? Clear? If it is a process of melting the ice, means converting the solid into the liquid, melting the ice and converting into the water, right? And again, if that happens at the same temperature, then we will apply the formula of latent heat of fusion. Fusion means ice to water, solid to liquid. Vaporization means liquid to vapors. Okay, formula is same for both latent heat of fusion and latent heat of vaporization, same formula, right? So how to find out the latent heat? Heater is 12 volt and heater is supplying a current of 2 ampere, right? So you see M1 minus M2, that is equal to 40 gram. So this much mass is evaporated, right? How this much of mass is evaporated? Because the heater supplied some heat energy Q, right? Heater supplied this heat energy Q to the water, means to this sample, and then 40 gram evaporated. Now we need to calculate how much heat is supplied by the water, by the heater to water, right? So we need to calculate Q, right? So you see, now this is M. M is equal to M1 minus M2 is equal to 40 gram. And energy is supplied by the heater to the water is Q. And if I divide this Q by M, then I will get latent heat, right? Means this divided by this, that will be latent heat of evaporation. Just a direct or just a very fast conceptual understanding. Heater is giving this, so input is Q, output is M. You see, what is here given to the water, Q, and coming out from the water is M. Just divide Q by M, that is latent heat of vaporization. Understanding my point? So latent heat of vaporization, that is LV. L stands for latent, V stands for power, can be written as voltage multiply current. So V multiply I multiply T. Just substitute the values. Voltage is 12 volt, current is 2 ampere, time is 3750 seconds. SI, can you tell me the calculation?
Not 100,000.
Anyone has calculator?
Yeah.
Yes, do the calculation if anyone has. Yes. How much? 2250.
No, that's the answer, sir.
Oh, where is Q? Okay. 9. 9 and how many zeros? 4 zeros? 1, 2, 3, 4. 4 zeros.
Actually, 6.
6 zero.
5
zero.
Five.
So this is energy.
Sir, 4. Wait, 4?
4 zeros. Just redo the calculation now.
There's 5.
No, it's supposed to be 5 zeros.
1, 2, 3, 4. Okay. 9 and then 5 zeros. And this is energy. And the unit of energy is joule. Right? So this is joule. Joule. So LV that will be equal to Q is 9, then 50, right? It is joule and divided by M. M is 40 gram, right? M is 40 gram. So divide this by 40. So divide this by 40. So mass is in gram. So LV that will be equal to, now SI just divide 90,000 by 4.
22.
How much?
22,000.
22500. Yes.
Is it car 20?
Which one?
No,
This
it's
one?
2.0.
No. 20 amperes.
No, it is 2.0.
Then it should be 90. Then it should be 90,000.
Okay, you thought it is 20. No, it's 2.0. It's 2. I just write 2 here. Now tell me finally, what is this?
It's 90,000.
90,000 only.
Yeah.
Oh, this 90,000 joule. So just cut 1 0 and mix now. Now 9,000 divided by 4. 2,250 and the unit is joule per gram, right? So this is latent heat of vaporization. Very easy, so easy, right? So from the diagram you can see Q is given to the water, heat energy Q is given to the water, and how much mass is evaporated. You just divide Q by M, you will get latent heat of evaporation. Okay. Okay, Madhavi. We have a polystyrene cup. A polystyrene cup, let me make the diagram only. So let me take, this is my polystyrene cup. Polystyrene cup. Polystyrene cup, that is a type of cup which is a good insulator, right? So this is insulator. Insulator. Right? And in this cup, we take a sample of water, means 250 gram of water is kept. 250 gram of water. So 250 gram of water is kept in this, right, polystyrene cup. And we want to make a cold drink, right? So what we have to do, we are also given the temperature of water, the temperature of the water, the temperature that is equal to 20 degrees C, right? 250 gram of water at 20 degrees C. So we want to make a cold drink. So want to make a cold drink. Okay. So what we have to do, we have a polystyrene cup. A polystyrene cup, let me make the diagram only. So let me take, this is my polystyrene cup. Polystyrene cup. Polystyrene cup, that is a type of cup which is a good insulator, right? So this is insulator. Insulator. Right? And in this cup, we take a sample of water, means 250 gram of water is kept. 250 gram of water. So 250 gram of water is kept in this, right, polystyrene cup, and we want to make a cold drink, right? So what we have to do, we are also given the temperature of water, the temperature of the water, the temperature that is equal to 20 degrees C, right? 250 gram of water at 20 degrees C. So we want to make a cold drink. So want to make a cold drink. Okay. So what we have to do is delta T, and we are also given the value of specific heat capacity of the specific heat for water, S is equal to 4.2 joule per gram per degree C. So what is this Q? Q is the amount of heat supplied, right? Amount of heat energy supplied by water to ice. Okay, so water will supply energy to ice because water is at high temperature, ice is at lower temperature. Energy, heat energy always flow from higher temperature to lower temperature, right? Water is at 20 degrees C, ice is at 0 degrees C. So when we put the ice into the water, heat will be transferred from water to ice. So how much heat will be transferred? So this much of heat. So amount of heat energy transferred from water to ice, okay? How much heat energy is transferred means that is a type of heat loss by the water, or that is a type of heat gained by the ice. Understanding my point? That is a type of heat lost by the water, or that is a type of heat gained by. Multiply 4.2 multiply 20, how much we will get? 21,000. And the unit of heat energy is joule, right? So this much of heat energy that will be lost by the water, and the same amount of heat energy that will be gained by the ice, right? So same amount of heat energy will be gained by ice. But how we can say same amount of heat energy? Because of this polystyrene cup, that is an insulator. So it will not transfer any energy to the surrounding. The entire heat energy from the water that will be given to the ice, right? It is an insulator, right? But one more thing, insulator also can, if it is not giving any heat energy to the surrounding, it can itself absorb. The material of the polystyrene cup that can absorb. But it is also given that even the polystyrene is not absorbing any heat, right? So whatever heat energy given by the water, that is given to the ice, not to the polystyrene cup, not to the surrounding, right? So only then we can say the cold drink, the first process that will start, that is specific heat capacity, means amount of heat. When we are just putting the ice into the water, then water will lose some heat, right? And how much heat is lost by the water? That is 21,000 joule, and same amount of heat that is gained by the ice, right? Now question is how much ice we added in the water in this process, right? So that finally T2 that becomes 0 degrees. So we have to find out the mass of the ice added while making the cold drink, so that final temperature of this cold drink that becomes 0 degrees C, right? Now when the final temperature is 0 degrees C, what it means? It means now there is no temperature difference. Now we have only one temperature. Ice, mass of the ice and mass of the water, they are at same temperature. Now which formula we will use? latent heat, right? So finally we are just adding the i's, right? So how much mass we added so that the final temperature that becomes equal to 0 degree C, we need to calculate this mass. So now this after some time, when ice and water they attain 0 degree C, right? Means now two different mass, ice. Now we will use latent heat of fusion, because ice to water, that is latent heat of fusion. But formula is same, that is equal to Q by M. And we are also given latent heat of fusion for water, that is equal to 330 joule per gram. That is also given, right? So now we can calculate how much mass of ice is added in this cold drink, right? So we can calculate M. So M, that will be equal to Q by LF. So M, that will be equal to Q. Q is from this 21,000 joule, right? So Q is 21,000 joule and LF is given 330 joule per gram. So this joule cancelled, this joule and joule cancel, so we will get the mass in gram. As I just do the calculation, 2100 divided by 33, how much we will get? 2100 divided by 33. 63.63 gram. So it means how much ice we added in this cold drink? 63.63 gram of ice. As I just do the calculation, 2100 divided by 33, how much we will get? 2100 divided by 33. 63.63 gram. So it means how much ice we added in this cold drink? 63.63 gram of ice is added into the water so as to make our cold drink and so as to attain the final temperature as 0 degrees C. So initially we were having the two different mass, ice and water, which were at two different temperatures. So we start with the formula specific heat capacity. And finally, when the cold drink is done, M1 and M2 means two different mass. Now they are at one temperature, that is 0 degrees C, right? So now when the two different mass they are at same temperature, now we will use the formula of latent heat of fusion. Okay, so latent of fusion, that is equal to Q by M. So from here already Q is calculated, M we can calculate from here if we are given LF. Okay.